Okay, guys, exponents. Unit 3, I think our fifth kind of mini unit, but our chapter 3 from our textbook. So our fifth test in this unit. Um, and a little bit different stuff. We will use some of the stuff we used in the past, but exponent laws are kind of independent here. Exponential functions have a lot of place in real life. It will get you ready for the zombie apocalypse. That's for sure. It'll make you respect how quickly zombies will take over the earth, and we'll get to that later. But now let's look at this. Okay, exponent laws. We're going to come up with exponent laws. Um, and why is this pen flashing? Should we do that? Let me pause this for a second. So let's come up with the laws here. So here we go. What's an exponent? Exponent is this little number that we put on top of another number. That's one way to look at it. So here it's 5 to the exponent 3. 5 is your base. 3 is your exponent. So in general, we have a to the n, a being your base. So this is your base, and this is your exponent. And what that means is 5 cubed, I'll work backwards here. 5 cubed is the same as 5 times 5 times 5. So 5, that's not decimal, it's 5.5.5. So 5 cubed means multiply 5 by itself 2 more times, or I see 3 5s. And 5 times 5 is 25, and 5 more of those, or 5 times that is 125. So that's what exponents are all about. We'll come up with some of the basic laws. I'll go back and forth between this page and this page that has the laws for day one. The first one is we have 2 cubed times 2 squared. Well, 2 cubed, let's just look at this. 2 cubed is 2 times 2 times 2. 2 squared is 4. So that times that is 32. Good. So we're just going to check to see that this is the same as what's going to happen here. So 2 cubed is 2 times 2 times 2. 2 squared is 2 times 2. So I'm saying I want this 2 cubed times 2 squared. And really, you can just say that's 2 times 2 times 2 times 2 times 2, right? Which is just removing this set of brackets, really, in the outer brackets. So everything's multiplying. And if I do that, that's 2 to the power of, well, there's 5 of them, 2 to the power of 5. So that is 2 cubed times 2 squared. As long as the base is the same, we can play around with this stuff. So exponent laws don't apply if the bases are different. So when I say, hey, what's 3 cubed times 2 to the 5th? This 2 and this 3 are not the same. None of these laws will apply. So all these bases are the same in everything. Okay, so that's 2 to the 5th. And so how do I get 5? You can guess, how do I get 5 from 3 and 2? Well, that's the same as 2, 3 plus 2. 2 to the power of 3 plus 2. So the first exponent law is multiplication. When you have a base, so if you have something like this, x to the m times x to the n, the resultant is x to the m plus n. So when you multiply, you add the powers. So multiplying goes with adding. What does dividing go with? You can probably guess. Multiplying goes with adding. Here, this is 2 to the 6th divided by 2 squared. So 2 to the 6th, what's that? 2, 4, 8, 16, 32, 64. Divided by 4, cut that in half twice, 32 and 16. Okay, so the answer is 16. That's also 2 to the 6th, which is this. See if I can make it fit. Divided by this. Okay, remember divide can be done like this, which is the same. And if we work it all out, it turns out to be 16. Or you can start canceling. 2 over 2 is 1. 2 over 2 is 1. And I'm left with 2 to the 4. And 2, so I have 2 times 2 times 2 times 2, which is 2 to the 4, which is itself 16. So it all works out. Okay, and how do you get this 4 from the 6 and the 2? You can probably guess it's subtracting. Take your powers and subtract. There's 6, there's 2. 6 subtract 2 is 4. Multiplying, when you multiplied, you added the exponents. When you divide, you subtract. And those things kind of go together, I think, right? Multiplying, when you think of a level below multiplying, you think of addition, right? Because what is addition? Multiplying. It's really just, that's 2 times 3, right? So multiplying is just a higher level of adding, and dividing is just a higher level of subtracting, I guess you can think of it that way, which isn't necessarily true, but just go with that, okay? Multiplying is adding, dividing, so you can either write this with a old-fashioned division sign, or you can write it like this, x to the m over x to the n, same thing, okay? And what you end up resultant is x to the m minus n, okay? So for example, here if I had 2 to the 5 times 2 squared, I get 2 to the 7, and if I want to divide 2 to the 5 divided by 2 squared, actually, you know what, let's not do that. Let's use 3 5, 3 is 8, just so we don't have too many 2's. That's 8. 5, 3 is, I can't get rid of my 2's, 2. 5 subtract 3 is 2. Okay, so those are the first rules. Next, I'm going to go to negative exponents, which I think is our fourth law or fifth law on our sheet. Negative exponents, same thing here with division. 2 to the 4 looks like this, and 2 to the 5 looks like this. Okay, 2 to the 5 looks like this. And when you start crossing things out, right, top, bottom, top, bottom, top, bottom, top, bottom, I'm left with 1 over 2. So I'm left with this 1 over 2. And one way to look at this is if I use this division law, I said that 2 to the 4 divided by 2 to the 5 is 2 to the 4 subtract 5, which is 2 to the negative 1. And in fact, 2 to the negative 1 is 1 over a half. And we can even take this a step further. If I had done this, let's just go a step further. 2 to the 6 here, that would have left me with 2 extra 2's on the bottom. That would have been 1 over 4. I have 2 to the negative 2, because I would have 2 to the 4 subtract 6. Okay, so here if I have 4 and 6, this, which is the same as 1 over 2 squared. And that's not an accident, okay? The negative 2, anything to the power of negative 2, and let's come up with the general, the negative exponent, so negative exponent. If I have x to the negative m, that's the same as 1 over x to the m. All right. Also, if I have 1 over x to the negative m, it also works this way. That's 1 over x to the m, which is x to the m. So if I have a negative power in the base, I can pull it up and make it a positive power. So for example, I'm going to write this here. If I have 1 over x to the negative 6, that's the same as x to the 6. Okay, bring that up like this. And if I have x to the negative 3, that's the same as saying 1 over x cubed. Okay, so if it's a negative exponent, it's 1 over the positive value of that exponent. Okay, so let me get rid of a little bit of that there because it's a bit of a mess. Okay, so we'll leave it at that. That's that. And okay, so that's rule number 5, 2 or 3 there. Let's add another page here and go over the power of a power. So if I had 2 cubed to the power, let's use different numbers here. Well, let's use 2, okay? Just because you can do these in your head. 2 cubed squared. 2 cubed squared means that's the same as saying 8 squared, and 8 squared is 64. So the neat thing about exponent laws is you can always prove them, and you can mess around with things and go in different orders and as long as you don't break any rules, you get the same results. So 2 cubed squared is 2 cubed, which is 8 squared, okay? Another way to look at it is that it's 2 times 2 times 2, which is 2 cubed, times 2 times 2 times 2. And if I went back to my multiplication rules, that's 1, 2, 3, 4, 5, 6 of them. So I have 2 to the 6. And we're going to come up with a basic rule here. If I have a 3 and a 2 here, how do I get 6 from 3 and 2? Well, it's 3 times 2. Okay? So it works this way. The basic rule is this. Wrong way. Basic rule is this. Power of a power. If I have x to the m to the n, I have x to the m times n. Okay, so for example, if I have 2 to the 7, all to the power of 3, it's 2 to the 7 times 3, which is 2 to the 21. Now, that's a big number, but those are the rules. Okay, 2 to the 7 to the power of 3 is 2 to the 7 times 3. And this is, which is 2 to the 21. Multiplication goes with adding. Dividing goes with subtracting. Power of a power goes with multiplying. I tend to think that it goes down a level. Okay, exponent one lower. So when you have adding, you go from adding, right, to multiplying. Okay, and then you have exponents, right, like the power of the power. So something to the power of something over here. Okay, and then you go down. How do you get the power of the power? You multiply. How do you go from multiplying? You add. Okay, so it's one lower level. That's how I think of it. Okay, so let me do another example here. If I had 5, if I had 5 cubed to the power of 7. Okay, that's 5 times 5 times 5, 7 times. That's 5 to the, let's not use 7, let's use 5 here. 5 to the 50. Okay, just multiply these out. Okay, and that's how it works. Power of power law, that's that. It leads us to, no, let's go back one. Let's get up with the 0 exponent. I should have done this earlier. If I had this, 3 squared divided by 3 squared. Our exponent rules say dividing is subtracting, so I end up with 3 to the 0. And then you go, what's 3 to the 0? What's that all about? I haven't seen that before. Well, 3 squared is 9, and 3 squared is 9. So it's 9 divided by 9, and 9 divided by 9 is 1. So now I'm telling you that 3 to the 0 is 1. What about this? What about x to the 5 over x to the 5? Well, that's x, 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 x. Okay, and they can all cross out. I'm left with 1 over 1 at the end, and that's 1. And the rule is, in general, anytime you get to a 0 exponent, anything, x to the 0, anything is equal to 1. And that applies also to fractions and that sort of thing. So if I even have something crazy like this, 1/6 to the 0, that's 1. If I have negative x cubed m squared to the 0, doesn't matter. Anything to the 0 is 1. Okay, so anything to 0 is 1. So that's our 5 main laws there. Power of a power, multiplication, division, power, like I said, 0 exponent, and negative exponent. The last law I want to go over, this is getting a little long for our video, is the last 2 laws are power of products and power of quotients. So things like this, 2x, even if I have this, 2x to the 5 squared. Okay, so that would be 2x to the 5 times 2x to the 5. And 2x to the 5 times 2x to the 5 would be 2 times 2 is 4x to the 5. Well, now I'm going to multiply these two. So x to the 5 times x to the 5. If you're multiplying, you add. So I end up with that. Now, is there another way to do this? Sure. It's 2. You take this exponent and you take it onto each part of the whatever's in here, the term that's in here. So if I have 2x to the 5, it's 2x squared. And x to the 5 squared is x to the 5 squared. Okay, and then you deal with that. 2 squared is 4. X to the 5 squared, you use the power of the power law. You multiply those two, 5 plus 2, or 5 times 2, sorry, is x to the 10. Okay, so that's that. The other one is the power of the quotient law. So in general, power of a product law, right out of the room there on the last page. So let's just do this. X to y m is equal to x to the m, y to the m. So that's power of a product law. Power of a quotient. Quotient, if you remember, is all about dividing. So the general rule is this: x to the y, x over y, sorry, all to the m is x to the m, y to the m. So how can I use that? For example, 3/2 squared, or 3/5 squared is 3 squared over 5 squared, which is 9 over 25. But this is the main part here, is that 3/2 squared is, I should have done it like this, 3/5 times 3/5 squared, sorry, is 3/5 times 3/5. That's 3 times 3 is 3 squared. 5 times 5 is 5 squared. That's how you get 9 over 25. Work backwards. That's the same as 3 squared and 5 squared. So anything to a power here, the power goes to the numerator and the denominator. And that includes negative powers, right? So if I end up with something like this, 1/2 to the -2, well, that's done 2 ways. One way you can flip this. The other way you can deal with this is 1/2 to the negative, or 1 to the -2, 2 to the -2. And we were talking about how any negative power means take it from the top to the bottom, bottom to the top. That'd be 2 squared over 1 squared, which is 4 over 1, which is just plain old 4. Now you can flip this with a fraction. The thing you do with a fraction is, if something is like this, you can just get the reciprocal and keep that power, change that power to the positive. So 2 squared, 2 over 1 all squared, and it turns out to be the exact same thing. 2 over 1 times 2 over 1 is 4. So that's I think exponents, if you like different things, you get bored by doing the same steps every time. I think exponents are kind of neat because you can play around with the rules and just use them different ways and figure out what you're doing. Okay, that's a bit of a long video, but that's a long review and a long note. Go through all the examples and always come back to the basic rules. If you're ever confused, the basic rules will take you there. Take care.